So let's start. सबसे पहले let me put this again in front of you. ILATE U के लिए बस remember ILATE. Okay, now what is your पहले तो check करो when do you need to use integration by parts. Your upper limit is 2 upon a, your lower limit is 0, and your function that needs to be integrated is, in few questions the question will tell you to use integration by parts. In the rest of the questions it won't, तो please इस बारे में जरा clarity रखना कि when to do what. सही है. Now what is the issue? Do you have two functions? X is one of them and the other is wrong. E to the power minus ax. These are the two functions that need to be integrated and both of them are multiplying. Be very clear. When it's adding or subtracting तो क्या करते हैं? Very good, we integrate them separately, but now they are multiplying. And now we need to be very careful while selecting U. What will be our U? Go with ILATE. What will be your U? Take your time. Do not be in a hurry. Jaldi sukun se jawab do. What's your U? What kind of functions do you have in this one? One is, what is X? What is X? What is X? What kind of a function is it? It's an algebraic function. E to the power minus ax is exponential function. तो u किसको लेंगे? Algebraic, right? So your u is x and your v dash is e to the power. Take your time, make proper data. Composure is required in these kinds of questions. Do not be in a hurry. I have mentioned the entire integration by parts formula. This will be provided in MF19, so do not worry about that. Acha, u dash, what will be u dash? 1. And what will be v? Now, what do you need to do to get v from v dash? Integrate. How do we integrate an exponential function? The power remains as it is, and we divide by the derivative of the power. Is this our v? Now remember, this is the integral we have, and we are supposed to break it into parts. The limit has to be applied on the entire thing. So please be very careful when you write it. What is your u now? X. What is your v? Minus e minus ax upon a. Minus, and when you integrate, you need the integral of v is minus e to the power minus ax upon a, and your u dash is 1. Remember, the part inside the integral still needs to be integrated. Do not forget about that. The thing that is inside the integral still has to be integrated. यहाँ तक clear है? And I have used long brackets for the limits. Why? क्योंकि the limits have to be applied on these parts too. बच्चे क्या करते हैं, इस पे लगाते हैं and they forget that this u and v still has to be in the limits. आराम से compare. Take your time. You have u in front of you. You have your u dash. You have the entire integration by parts. Write it whenever you have to, because it will be mentioned in MF19. You do not be in a rush. So this is minus x e to the power minus x upon a. Remember, this still has to be integrated. When you integrate it, so you can write plus 1 upon a outside if the integration is confusing you, and then you can use the integral sign. This is just for your ease. It won't change your answer in any way whatsoever. इससे लिखने से थोड़ी सी जो confusion है, because that will be eased. because a is a constant. उसको बाहर लिख लिया. Now what will be the integral of e to the power minus ax? We have just integrated it, so we can integrate it again. What do we get? The entire thing as it is. And the integral of this is e to the power minus ax upon negative a. Make sure you simplify because all of this will become very chaotic very soon. तो थोड़ा simplify करके make it easy for yourself. यहाँ तक everything is clear. Now, can I just take e to the power minus ax common? And I'm left with minus x upon a minus 1 upon a square. Upper limit is 2 over a, lower limit is 0. How does this make things easy for me? एक ही जगह पे now I have to plug in the values. I will not be confused for the values again and again. So when I plug in the value 2 upon a, what do I get? 2 upon a. E to the power minus 2 and then minus 2 over a square minus 1 over. Is this right? And when you plug in the value 0, what do you get? 0 ये बन गया 1. This is 0 and minus 1 upon a square. Is this right? So this is 1 over e square minus 3 over a square minus minus plus 1 over a square. 1 over a square can be taken as common, minus 3 over e square plus 1 or the same thing can be written as 1 over a square 1 minus 3 over e square. Okay, so let's try to integrate this x tan inverse of 2x. In part A, we already did the differentiation. 2x is tan y, so the derivative is dy by dx is 2 upon 1 plus x square. So in other words, tan inverse of 2x का derivative is 2 upon 1 plus x square. Now remember, while selecting u, we must keep ILATE. पहले हम भी late पढ़ाते थे. It was late for your syllabus. Now inverse trigonometry is a part of your syllabus. So now it's ILATE. So what must be u in this case? Tan inverse of 2x. Okay, you do not know the integration of this. And what will be your v dash? X. So yeah, I have put the formula for you. What will be your u dash? Abhi, we just did it in the first part. Tan inverse of 2x ka derivative is 2 upon 1 plus 4x square. And what will be your v? X square upon 2. So now remember, this is what we are breaking. And this is how we are breaking it. So you'll break it into u into v minus integral of v u dash. So I'll use long brackets for the limits because the limits have to be applied on the entire thing. What is my u? That is tan inverse of 2x. What is my v? X square upon 2 minus integral of v is x square upon 2 and u dash is 2 upon 1 plus 4x square. Long bracket, upper limit is square root 3 upon 2. Lower limit is half. Is this clear? Now what? Let's simplify. X square tan inverse of 2x upon 2 minus integral of x square upon 1 plus long bracket. Yes, now what? How do we divide this now? Because it is a proper fraction, it can be further divided. So how do we divide this now? Quotient will be 1 upon 4. And when it multiplies by 1 upon 4, we'll get x square plus 1 upon 4, which is quarter. You can write it as a decimal as well. And when you will subtract it, ये cancelled out हो जाएगा. And your remainder will be minus 1 upon 4. Is this right? क्योंकि हम highest powers देखते हैं 4x square को if I want to cancel from x square, I'll have to multiply it by 1 upon 4. 1 upon 4 is my quotient and my remainder is negative 1 upon 4. Is that right? So now how do I write a fraction when I break it into quotient and remainder? Remember, this still has to be integrated. 1 upon 4 is my quotient. My remainder is 1 over 4 and into 1 plus 4x square. Is this clear now? I've told you, दोबारा देख लो. अगर मैं, for example, if I give you 10 upon 7, what is your remainder and what is your quotient? What is your remainder and what is your quotient if I give you 10 upon 7? 1 is quotient and 3 is remainder. So you can write the entire fraction in this way. सही है? So my quotient was 1 over 4. वाला लिख लिया quotient plus remainder was 1 over 4 upon divisor वो already यहीं पे था तो उसको ऐसे लिखा. So now I can take this entire 1 over 4 common as well. Right? Now how do I integrate this bit? 1 is easy. 1 is easy, but how do I integrate the remaining things? IMF 19 I showed you for a reason so that you can relate. Which one will you want to relate it to? और से देखो. First one, 1 upon x square plus a square. Now you want just an x square over here. सही है? तो आप क्या, what will you take as common? 4 common ले लेंगे ना if you want to relate it to, because students prefer it this way as there are easier ways to do it as well. Or the best is the one that you have done earlier. See, और से देखो, if I take the 2 common, दोबारा से, the derivative of tan inverse of x is 2 upon, अगर मेरे पास यहाँ 2 आ जाएगा तो can I write the integral is tan inverse of 2x? If I have this as the derivative, 2 upon 1 plus 4x square, इसका integral will be tan inverse of 2x. I'll break it down further. Don't worry. मैं इसको एक और break करके बताता हूँ. Don't worry. परेशान नहीं. Okay, I'll break it down for you further. 1/4 and 1, and remember 1/4. Is this right? सही है. 1/4 को दोनों इंटीग्रल्स के साथ लिखा. एंड नाउ -1/4 था, तो दिस विल बिकम +1/4. यहाँ तक क्लैरिटी है. Now, if I just give you use reverse differentiation in this case, if you just have, अगर आपके पास, if you would have had a 2 over here, you would have used reverse differentiation and made it tan inverse of 2x. You do not have a 2 over here. You can just multiply the numerator by 2 and the denominator by 2 as well, and this will become 1/8. Now you can use reverse differentiation to integrate this bit, and this will be tan inverse of 2x. Now I am writing the integrals, and then we will apply the limits. एक एक करके, let's see. So the integral of this is x, and the integral of this is tan inverse of 2x. Make sense? Clarity here? Just use a bracket here as well. So 9. If you have a 4x square as the denominator, its derivative would have been 8x. You would have had an x in the numerator. You cannot introduce a variable on your own. You can introduce a constant though. जल्दी से करके बताओ क्या. I'll put the limits. Tell me the exact answer. सही है. I've told you when you are plugging it in the calculator, put the trig part separately and the non-trig part separately. So square root 3/2 का square. You want to find the square of square root 3/2, and you're squaring the entire thing. That is 3/4. फिर वो upon 2 से हो गया. That is 3/8. So this is 3/8 and tan inverse of 2x. So tan inverse of 2 into square root 3/2. Obviously, you could have simplified it, but just letting you know, if you are so adamant with using the calculator, पहले तो make sure your calculator is in radians. It is pi/3. Pi/3 से cancel हो गया, and I have pi/8 minus square root 3/8 plus pi/3 आया है, and this is pi/3. So pi/24. This is for the upper limit. Minus the lower limit, half का square 1/4. This is 1/8. Where tan inverse of 1 is tan inverse of 2 into half is 1, which is pi/4. So pi/32 minus 1/8 plus pi/32, pi/4. और so now simplify, ये तो cancel हो गया मेरे पास. simple pi/8 plus, नहीं cancel नहीं हो, plus हो गया. So I have all, let me add all the pi's. Pi/8 plus pi/24 minus pi/16. So 5 pi over 48. And then I have square root 3/8 plus 1/8. This is how I can leave my answer. This is an exact value. I can obviously convert it into a single fraction as well, but this is good enough.